Okay, this is number 11. Estimate the integral from 0 to 120 by using right Riemann sums with 6 intervals. So remember what we're actually finding or what they're wanting us to do. They're wanting us to find the area in the curve from 0 to 120 using the right-hand side of my rectangle. Okay, so you don't have to make a sketch of this if you don't want to, but starting off, I always kind of need a little picture. So I'm going to just sketch the first few points, and then you tell me if you, you can't tell me, but we'll see if we can find a pattern. So when x is 0, f of x is 1.3. So 1.3, there's my first point. When x is 20, f of x is 2.4. So remember, f of x are our y values. And I don't care if these are to scale, I'm just kind of making a sketch. When x is 40, f of x is 1.1. And at 60, it's 3.6. Okay, and we can make the others if we need to. I'm going to stop right there and see what it looks like. All right, so I'm using 6 intervals. Well, can you tell when? Here's 1, 2, 3, 4, 5, 6. So they've given me nice little intervals already. So if the right-hand side of my rectangle has to touch, all right, here's my first rectangle. Here's my second rectangle. Here's my third rectangle. Okay, and then I could finish the pattern. But let's see if we can write down what the areas would be without having to sketch all of them. So from 0 to 20, so from 0 to 20, the base of that is 20 times the height of this. Well, the height, do you see that we don't use this first number because that would be the left-hand side of my rectangle? So I'm not using that at all. But the height of it is 2.4 plus. Here's my second rectangle. From 20 to 40, my base is 20. My height is whatever it is at 40. So I'm using 1.1. Plus, here's my next rectangle from 40 to 60. My base is 20. So you see our base is going to be 20 for all of them because they're nice, even intervals. The height of this one is 3.6 plus. So do you see, without having to draw the rest of the rectangles, what my base is? So my next one from 60 to 80 would be my base is 20. My height at 80 is 3.4 plus. Down to the next one from 80 to 100. My base is 20. My height from 80 to 100 is 2.1 plus. My last one is from 100 to 120. So my base is 20. My height is 3. Okay, so you could go through and sketch them all out, but you don't have to. Okay, now if I did my arithmetic right, you should get 312 when you add all those up. So here's 1, 2, 3, 4, 5, 6 rectangles. Okay. Number 12. Find the area of the region bounded by the graphs of the equations y equals x squared plus x, x equals 0, x equals 2, and y equals 0. Okay, so first of all, I could make a sketch of this. I'm going from 0 to 2. So if I want to see what the sketch looks like and it's not a calculator problem, just start plugging points in. At 0, when I plug 0 in here, it is 0. When I plug 1 in, 1 squared plus 1 is 2. And then when I plug 2 in, 2 squared plus 2, that's 4, that's going to be 6. So I'm going to say that's 6. So we know this is a parabola because it's x squared. So when I sketch this in, and this is going to be bad, but I just need to make sure that it's not a straight line, it's actually a curve. So find the area of the region bounded by the graphs. So here's the region they're wanting us to find the area of. And it kind of looks like a rectangle, but it's not because that's a curved line. So what we need to do is set up our integral. I know I'm going from 0 to 2 of x squared plus x dx. So now I'm ready to integrate. X cubed over 3 plus x squared over 2, and I'm evaluating from 0 to 2. So now I'm going to plug my 2 in. 2 cubed over 3 plus 2 squared over 2 minus 0, because when I plug 0 in, I'm just going to get 0. So that's 8 thirds plus 4 over 2, which is 2. And 8 thirds plus 6 thirds would be 14 thirds. Okay, and we'll stop right there. We'll do the next ones on the next video.